All right, so let's go ahead here and take a look at some limits, all right? Now, what we'll discuss and what you guys are going to figure out, of course, is that limits describe effectively the y value that we get closer and closer and closer to as we approach a particular x value. But the way these things look on exams and such tend to be a little bit quirky, but luckily they fall into different categories or buckets. So in the interest of sort of explaining how those look, let's go ahead here to this example which says, let's let p equal the limit. Now beneath that it says as x, essentially we say that as x approaches 5 for f of x, where f of x is this expression right here, go ahead and find p. So either you can do this in your head or you can do it the long way. I'm going to just show you real fast that our first step is always going to be to plug the number right on in. Okay, in other words, your best guess for the y value that we approach as you get closer to 5 is the y value that you smack dab run into when you arrive at 5. So let's plug in 5 before we even start. Now again, some of you are going to get good at doing this in your head, but for now, let's go ahead and just show how this works. So if you plug in 5 there, you'll get 5 squared minus 5 times 5 all over 5 squared minus 7 times 5 plus 10. Now, where's that going to get us? Well, unfortunately, on the top, that's going to give us what? 0. And on bottom, it'll take a second, but if you do 7 times 5, that gives you 35, right? This is 25. 25 minus 35 gives you negative 10. When added a positive 10 gives you 0. Now, that right there is an extraordinarily common occurrence that we get 0 over 0. Okay? So how do we, quote unquote, fix that? All right, well, this is where we have to do what's called evaluate the limit and cancel some stuff out. Because this thing is what's called a rational function, meaning there's a polynomial on top and a polynomial on bottom, your gut instinct needs to be factor. I got to factor this thing somehow or another. So if it's okay by you, I'm going to get rid of this work because it really isn't needed to solve the question. That was just to kind of figure out what bucket it fell into. So let's go here and do the following. The top is going to factor as x times x minus 5. And the bottom is going to factor as what? It's ugly. Jeez. Okay. And the bottom is going to factor as, let's see, we got x and x. And if you do the math on this one, we should get 2 minuses, right? And I believe one is minus 5, one is minus 2. Now, I want to be clear, though. This right here is technically not exactly correct. What you have to do is the following. When you take something and factor it or play with it in any way, you have to always write the following. I'm going to write in cursive here, limit as x approaches 5. If you don't write that, they will take off some partial credit sometimes, all right? So we got limit as x approaches 5 of this expression here. Well, now what do we do? Well, we'll notice that the x minus 5s all cancel. And that's going to give us, now notice our next step is still to write limit as x approaches 5 of what? Well, we end up getting x on top and then x minus 2 on bottom, yes? Great. Now that we've canceled something, what we're going to do is we're going to plug in 5. In other words, try it again now. Before we got 0 over 0. But by eliminating that thing, perhaps the 0 over 0 nonsense goes away. So that gives us 5 all over 5 minus 2. And ultimately, there's our answer. It turns out that the limit as we approach 5 is just going to be 5/3. All right, so that's our first sort of category, so to speak, of the 0 over 0 limit. You plug in the number, get 0 over 0, but if it's a polynomial on top, polynomial on bottom, just factor them out, and something will cancel. Once that something cancels, you can then stop writing limit and just legitimately plug it in and see if you get a legitimate answer as we did here. All right, so let me show you another example of what this might look like. Let's go right here, and of course I spaced these out. Let's go ahead and find the limit as h goes to 0 of this function which I very cleverly called g of h, where g of h is the expression 3 plus h all over 3 minus 1 all over 1 plus h all over h. Well, what's my first step always? Either mentally or otherwise, I'm going to plug in 0 for h and see how it goes. That gives me 3 plus 0 over 3 minus 1 all over 1 plus 0 divided by 0. Well, hopefully we can see on top, that's going to give us 3 over 3, which is 1. Minus 1 over 1, which is 1. And then you do 1 minus 1, gives you 0 over 0. Boo. So unfortunately, we're back in that same predicament where we don't get an answer, we get 0 over 0. Well, this looks a little bit different. Do we notice that I have what? I have fractions and stuff on top, right? It's not just polynomial on top, polynomial on bottom, but it's fractions and all that. So what I'm going to do is I'm going to find a common denominator on the top and then use that to then reevaluate. So here we go. Now remember, I have to write limit as h goes to 0 of what? Well, now I'm going to space this out just a little bit on purpose. So I'm going to write 3 plus h over 3 minus 1 all over 1 plus h all over h, right? And now what I'm going to do is this. How do you get a common denominator for just the stuff on top? Well, if we'll notice, this guy on the right gets multiplied by 3 over 3. Yes? This guy on the left gets multiplied by 1 plus h over 1 plus h. You see where this is going? It's a common denominator for just the stuff on top. All right? So let's kind of move that forward a little bit. And again, I'm writing kind of goofily large here, but you'll deal with that. The limit as h goes to 0 of what? Well, look, if you basically multiply this out, you get 3 times 1, which is 3, plus 3 times h, which is 3h, plus h times 1, which gives you h, plus h times h, which gives you h squared. Now, that's for that first part on top. It's divided by what? It's divided by this very ugly, and I'm going to leave it ugly, 3 times 1 plus h. Just leave it alone. Don't feel the need to combine the bottoms. Only combine the tops as needed. This is then going to be minus what? Well, this guy's not too bad. It's 3 all over, again, that same ugly 3 times 1 plus h. And if we recall, the whole darn thing is over h. All right, so what we're going to do now is hopefully get rid of some stuff. Let's keep on going. The limit as h approaches 0 of what? Well, if we combine the tops on top, ironically, we're going to get 3 minus 3. Do we see that? So hopefully we can see the writing on the wall and notice those 3's are going to cancel. So if it's okay by you, I'm going to combine the tops just by starting with the 3h plus h, which by the way is 4h, plus h squared, all divided by that ugly 3 times 1 plus h. But now check this out. Instead of dividing the whole thing by h, I'm going to do this nonsense. You see that worked? And by the way, the reason why I do that is because if you just keep on trying to plug in h equals 0 right now, it won't be successful. You're still going to get 0 over 0. Our whole purpose is to cancel something out. Something's got to cross out like we saw previously. So let's go ahead. I'm going to move to my right here now and say the limit as h goes to 0 of what? Well, on top there on the left, I can pull out an h. So let's make it h times 4 plus h all over 3 times 1 plus h times 1 over h. Do you see what's happening? I see it. Oh, baby, look at that. The h's canceled. Remember I said we're looking for something to cancel. Since now something is canceled, I think I'm going to be home scot-free. Let's see. This is going to be, it's annoying, but the limit as h approaches 0 of just the expression 4 plus h divided by 3 times 1 plus h. Well, now that I got rid of something, let me just stop this nonsense of writing the limit as h goes to 0 and let me plug in 0 for h. I mean, let's go 4 plus 0 divided by 3 times 1 plus 0, and that's going to give you 4 on top divided by 3 on bottom. And there, ladies and gentlemen, is our answer. It's a whopping 4/3. All right? So in the interest of being just thorough, let's do one more iteration here, and let's take a look at this guy. Okay, let's go ahead and let's evaluate the limit as a approaches 2. By the way, I picked a arbitrarily. We can pick whatever letter we want. It doesn't really change the way we do these things. So the limit as a approaches 2 of the expression a minus 2 divided by the square root of the quantity a squared plus 6a all minus 4. All right, well, listen, what's our first go of it? Mentally or otherwise, I'm going to plop in 2 and see how it goes. Something tells me it ain't going to go so hot, but let's find out. 2 minus 2 divided by the square root of 2 squared plus 6 times 2 all minus 4, right? Okay, the top I can see pretty clearly it's going to be 0. The bottom maybe is going to require a little more convincing. 2 squared is 4 plus 6 times 2 is 12, right? So that's going to be 4 plus 12 under the radical there, or 16. The square root of 16 is 4. So then when you take that 4, subtract that 4, hot damn, you get 0 over 0. Okay, so now that we know that's the case, we have to take this thing and play with it in some way. Now, it's not a polynomial on top and a polynomial on bottom. It's not stuff with fractions floating around. Instead, it's got a what? It's got a root. Do we see that? It's got a radical. Since it has a radical, our best way to handle it is to use something which is called the conjugate. Let me show you how that works. So let's go ahead and just write this as the limit as a approaches 2 of the expression a minus 2 divided by what? Well, the square root of a squared plus 6a minus 4. And now what does a conjugate look like? Well, since it's super ugly, I'm going to write it here in purple, which is a nice ugly color. And now we're going to do the following. The conjugate is this bad boy's, quote unquote, some folks call it their opposite, which is not right, but that's fine. So what we're going to do is we're going to effectively rewrite this expression as the square root of a squared plus 6a. But instead of subtracting 4, guys, we're going to do what? We're going to add 4. And same thing goes here. We got the square root of a squared plus 6a, all plus 4. Do you see where this is going? Now watch what happens. I'm going to rewrite this in blue in the following way. It's a limit as a approaches 2. And in the numerator, we're going to have this ugly thing, which I'm going to leave super duper ugly. I mean, it's going to be the quantity a minus 2 times this nonsense, square root of a squared plus 6a, all plus 4, right? But on bottom, things look beautiful. Here's the way it works. Whenever you multiply something by its conjugate, and so these guys are near twinsies, right? These things have conjugates. What happens is always the same effect. It's always the first thing squared, always a minus, and then the second thing squared. So what's going to happen is, guys, when I take the expression, the square root of a squared plus 6a, when I take that bad boy and square it, the square root just goes bye-bye. And we end up getting a squared plus 6a, always a minus, and then 4 squared is what? Well, that's a good old 16. Do we see that? Now, our goal here is to make something cancel, so watch where this is going. This is going to be the limit as a approaches 2. Again, I have to keep on rewriting that. So long as I have variables, I have limits. It's only once I know that it's time for me to plug back in that I can do away with that stuff. So let's see. The top is still going to stay right the way it is. A minus 2 square root of a squared plus 6a, all plus 4, divided by what? Well, our bottom is going to be a whopping a minus 2 times a. I'm guessing it's plus 8. I can double check that, right? Negative 2 times positive 8 is negative 16. Awesome. Negative 8 minus 2, I'm sorry, positive 8 minus 2 gives us positive 6. All's looking well. Now, what do we notice happens if you do this? Oh boy, those a minus 2's cancel. And again, I'm like, good, I'm home free now. Let me just rewrite this one more time. The limit as a approaches 2 of what? Well, in the top, it's just that ugly square root of a squared plus 6a, all plus 4, divided by a plus 8. So now that I've got that thing canceled, what's my next step? The answer is just go ahead and plug in 2 for a and see how it goes. That is the square root of 2 squared plus 6 times 2, all plus 4, divided by 2 plus 8. Well, in the numerator there, 2 squared is 4 plus 6 times 2 is 12. So 4 plus 12 gives us 16, right? So the square root of 16 is going to give us 4. Plus the existing 4 all over what? All over 10. Well, that gives us 8 tenths. Take your time here. Don't be a hero. 8 tenths. And I believe out the door, that gives us 4 fifths. So there, ladies and gents, are the 3 most common 0 over 0 limits we will see.